Hello, friends! In the previous video, we talked about bit depth and how more bits give you more detail. But there was one little formula hiding behind everything we discussed. 2 raised to the power of n. In this video, we're going to break down exactly what 2 to the n means, why it shows up everywhere in computing, and why doubling is the real magic behind how computers store information. Let's dive in. All right, let's start with the basics. When you see 2 to the n, the 2 at the bottom is called the base. That's the number we're multiplying. The little n sitting up top is called the exponent, and it tells us how many times we should multiply that base by itself. So 2 to the power of 3 simply means 2 times 2 times 2, which gives us 8. That's it. No complicated math, just repeated multiplication. Now, let's see why this little formula is so important in computing. Here's the part that makes 2 to the n so powerful. Every time you increase n by just 1, the result doubles. With 1 bit, you get 2 combinations. Add another bit, and it jumps to 4. 1 more bit, and you're at 8. Then 16, then 32, and so on. Notice how fast this grows. We're not adding, we're doubling. This is called exponential growth. And it's the reason a small number of bits can store a huge amount of information. Just 10 bits already gives you over 1,000 combinations. That's the magic. Let me show you this with a real example. Say we have 3 bits to work with. Each bit can be either a 0 or a 1. So if you list out every possible on-off pattern, you get exactly 8 unique combinations, from 000 all the way to 111. And that matches our formula perfectly. 2 to the power of 3 equals 8. Each of these patterns can represent something different. A color, a number, a character, anything you want. This is how computers turn simple zeros and ones into meaningful data. Now, let's see where 2 to the n shows up in the real world. And trust me, it's everywhere. Take colors. The vibrant images you see on your screen use 24 bits per pixel, which gives you 2 to the 24 or 16.7 million possible colors. Storage works the same way. 1 kilobyte isn't 1,000 bytes. It's actually 2 to the 10, which is 1,024 bytes. The internet runs on this too. The older IPv4 system uses 32-bit addresses, giving us 2 to the 32, or about 4.3 billion unique IPs. And even password security depends on this. Every byte of a password gives you 256 possible values to guess from. So whether you're scrolling Instagram, watching YouTube, or sending a WhatsApp message, 2 to the n is quietly running in the background. Here's something that'll blow your mind. Watch how fast 2 to the n grows. Start with 1, double it, and you get 2. Double again, 4. Then 8, 16, 32, 64, 128. Looks slow at first, right? But keep going. By the time you reach 2 to the 64, the number explodes into 18 quintillion combinations. That's an 18 followed by 18 zeros. This is exactly why 64-bit systems can handle massive amounts of memory and data. A small jump in n leads to a gigantic jump in the result. This is the real superpower of exponential growth. It starts quiet, then suddenly becomes huge. All right, let's quickly wrap this up in 3 points. 1, 2 to the n simply means 2 multiplied by itself n times. Nothing fancy, just repeated multiplication. 2, it's the formula that tells you exactly how many unique combinations you can make with n bits, which is why it powers everything from colors to memory to network addresses. And 3, its real superpower is doubling. Every time n grows by just 1, the total doubles. And that's how computers handle billions and trillions of possibilities with surprisingly few bits. If this helped the concept finally click for you, smash that like button and subscribe to Webronaq for more simple, clear tech explanations. See you in the next video.